Before we start with the complicated volumes, let's start with linear distances. Every centimetre has got 10 millimetres in it. Every metre has got 100 centimetres in it, and every kilometre has got 1,000 metres in it. So, if we looked at centimetres, that is 1 centimetre is 10 millimetres, properly, and 10 lots of 100 is 1,000 millimetres, makes a metre, and 1,000 times 1,000, that's 1,000,000 millimetres, make a kilometre. So let's have a look at a quick example. I want to convert 50 centimetres into millimetres, into metres, and into kilometres. Now, to convert them into millimetres, obviously every centimetre's got 10 millimetres, so I've got 50 centimetres, and for each one of those I've got 10 millimetres. That's 50 times 10 is 500 millimetres. Now, with converting centimetres to metres, we know that there are 100 centimetres in a metre, so we're going the other way this time. So metres are a bigger unit of measure, so I expect my number to get smaller, because if I've got 50 centimetres, it's got to be fewer metres than that, because metres are bigger than centimetres. So this time, we're dividing by 100, so 50 divided by 100. And that gives us 0.5 metres, so 50 centimetres is half a metre. Now to convert 50 centimetres into kilometres. Well, if I did 50 divided by 100, that told me how many metres there are, and we know that there are 1,000 metres in a kilometre, so it's going to be 1,000 times smaller than that. So I've got to do 50, divide by 100 to turn it into metres, and then divide by another 1,000 to convert it to kilometres. And that's 0.0005. So essentially, we start off with our 50. Now each time I divide, if I divide by 100, I've got to move imagine that as 50.0, I've got to divide by 100, so I need to move that decimal point 2 places to the left. To divide by 1,000, I need to move it another 3 places to the left, 1, 2, 3, and that's where my new decimal point is going to be. So filling in the gaps, that makes 0.0005, which was the answer we got here. In this next example, we've got 1.7 kilometres, and I want to convert that into metres, centimetres, and millimetres. Now we know that there are 1,000 metres in a kilometre, so there'll be 1,000 times as many metres as there are kilometres. And 1.7 times 1,000, that means I'm moving the decimal point 3 places to the right, which gives me 1,700. Now, there are 100 centimetres in every metre, so I need to take 1,700. And I need to times that by 100 to convert from metres to centimetres, which gives me 170,000 centimetres. Then there are 10 millimetres in every centimetre, so I need to multiply that answer by 10 to convert to millimetres. And that gives us 1,700,000 millimetres in 1.7 kilometres. Now I think we're ready to go on to volumes. Here's a cuboid, which is 1.2 metres in this direction, 1.5 metres in that direction, and 1.6 metres in that direction. To work out the volume of this, I simply multiply the three together. And 1.2 times 1.5 times 1.6 gives us an answer of 2.88 cubic metres. So that's a nice easy question. However, often in exams they make things a little bit harder by asking you to give your answers, for example, in cubic centimetres rather than in cubic metres. Now the best way to approach that sort of question is to draw your cuboid out again, and instead of writing your units, your original units, in metres, let's write them in centimetres. So we've got to do our linear conversions. 1.2 metres into centimetres. Remember, there are 100 centimetres in a metre, so I need to multiply each of those distances by 100. So that's 120 centimetres across, 150 centimetres in that direction, and 160 centimetres tall. Now I multiply those together. 120 times 150 times 160 is 2,880,000 cubic centimetres. So that would be my answer. Now, having known that the original was 2.88 cubic metres, I could simply have multiplied that by a million if I knew that there were a million cubic centimetres in a cubic metre. But that's another whole bunch of things to remember. Far easier to remember the linear conversions from meters to centimeters, and then to redraw your original problem in terms of the units you're looking for, and then do the calculation in the correct units. So a bit more work in the short run, but much easier to remember and much more likely to get it right in the long run. However, even that's not the end of the story, because actually in exams they make it even harder, and they don't give you a cuboid, they just give you a value to convert. But this isn't a problem for us, because what we can do is we can draw one anyway. We can imagine a shape which is 4.9 cubic meters, and to do that I'm going to draw the following. That's a cuboid which is 1 meter by 1 meter by something across here. We'll work out what it is in a minute. But 1 times 1, so the cross-sectional area of this is 1 times 1, that's 1 square meter. Now what do I need to multiply that by, in the terms of the length, to get my 4.9 cubic meters? Well, clearly 1 times 4.9 is going to make that answer. So for these ones, we can always draw our sort of imaginary shape. It doesn't have to be the same shape that the original shape was, but it's got the same volume, 4.9 cubic meters, 1 unit high, 1 unit across, and then the length of this shape will be whatever answer you were given in the first place, 4.9 meters. Now we can convert those into centimeters. So remember, there are 100 centimetres in a metre, so our 1 metre across, is going to be 100 centimetres, our 1 metre across is going to be 100 centimetres, and our 4.9 metres in that direction is 490 centimetres. Now I can just do my calculation. So that's 490 times 100 times 100. That's the shape of my imaginary cuboid. And that's 490 with another 2 zeros with another 2 zeros, and then sort of work your way back and put these the commas in. That's 4,900,000 cubic centimetres. Again, if you remember there are a million cubic centimetres in a cubic metre, that's fine. If not, we've only got the linear conversions to remember, and this gives us a way of working out the correct answer. So our last example is in the other direction. These are probably the hardest questions. 275 cubic millimetres needs to be converted into cubic metres. So we're going to draw our notional cuboid. So that's going to be, we've got our original units are in cubic millimetres, so I'm going to have 1 millimetre up, 1 millimetre across, gives me an area of 1 square millimetre, and I'd need to multiply that by 275 millimetres in this direction to get my volume of 275 cubic millimetres. So now I need to convert those units into metres, and remember there are 10 millimetres in a centimetre and there are 100 centimetres in a metre, so I'm going to have to take my 1 millimetre across here, divide that by 10 to give me the number of centimetres, and divide that answer by 100 to give me the number of metres. And when I do that, moving the decimal point left 1 place and then 2 further places, I get 0.001 metres. And carrying on with the height is also 0.001 metres, and the length of this block, again divide by 10 and then divide by 100, that's 0.275 metres. Now I need to multiply these three together. And when I do this, I get 0.0000275 cubic metres. Just a quick recap of how we got that answer. We took our 0.275 metres and we multiplied by 0.001. So that is basically dividing by 1,000. So every time I divide by 1,000, 1, 2, 3, my decimal point will move back to here. And then I've got to divide by 1,000 again. 1, 2, 3. So this is where my new decimal point is going to end up. And that's what that number is going to look like. That gives me the 6 zeros in front of my 275.